All right, so we are working on this Chapter 7 test review sheet, and let's just get started trying to get you prepared for this test coming up. This first problem involves multiplication of rational expressions, and so your goal here in problems 1 and 2 will be to first factor everything that is possible to be factored. All right, so I don't see a possibility of factoring this numerator, and that's also true for the denominator. But when I jump across to the other fraction, this numerator here, do you notice that the terms are basically switched? They're in reverse order. So in cases like this, this is where we factor out -1 so that we can arrange them properly. So factoring out -1 will allow me then to put the k term first, and you basically just switch places with these two terms, and then we'll be able to factor that more in just a minute. Well, let's just go ahead and factor that now so you can see it. Obviously, hopefully you can see that it's the difference between two squares. So instead of showing it like this, let's show it as k plus 1 times k minus 1. All right, so we won't look at this any longer. We've got it now in fully factored form, but just want to re-emphasize that factoring out the -1 is necessary. You can't just arbitrarily switch places with those terms. You can do it by factoring out -1. And then this denominator, we're going to factor it using the factors of +3 that add up to -4, and that will be k minus 3 and k minus 1. So now that you've got all the factoring accomplished, now you just start looking for matching factors. And so your canceling can take place. I'll just make some arrows. We can go in these two directions. We can go diagonally and look for matching factors. And you can also go vertically within a fraction. Okay, so I can go above and below within a fraction, or I can go diagonally between the two fractions. I just can't go straight across. Okay, so don't try to cancel going this way or across the top. That's not going to be allowed. Okay, so let's see what we end up with after every matching factor has been canceled out. So that means these k plus 1s will go away. These k minus 3s will go away. And then we also have this pair of k minus 1s here that will cancel. Okay, so it looks like everything cancels except for this lone -1 here, and that ends up being my final answer for number 1. All right, so the key is factoring. If you can factor, then the rest of this is going to be pretty easy. Okay, let's see how number 2 works. I'm going to start factoring here. Factoring should always begin with looking for a GCF, and I see there's a GCF here that's 2. So when I factor out the GCF, I get 2 times d plus 3. Below that, I see the factors of -2 that add up to +1. So that will be +2 and -1. So there's the factoring of this denominator. For division problems, we need to change them to multiplication. So you change the symbol from division to multiplication, but then it's going to be required that you flip this second fraction. Okay, so this denominator is really going to go as the numerator down here. So let's just go ahead and factor it. The factors of 2 that add up to 3 are d plus 2 and d plus 1. And then this numerator in the old problem, when I flip it, obviously becomes the denominator. And so once again, we're back to the similar problem that we have with number 1. We just look for matching factors that we can cancel. We can cancel factors, we just can't cancel terms. All right, right? So all those factors cancel. So what doesn't cancel will end up being my answer. And when you do the test, there's no need in cases like this to do the distributive property with 2. You can just leave your answer in factored form, and that's it. Everything factored out, cancel out matching factors, and then you are done. And this is really, number 3 is a lot like number 2. It's written differently, but this is also a division problem. So it's like saying we're dividing by this fraction, okay? So I'm going to set it up as multiplication. I'm just going to rewrite it in the way that should be written, and then we'll go through the factoring process. Okay, so I don't do anything to this top fraction. It's what I'm dividing by that needs to flip. Okay, so I'm going to change division to multiplication, and then I'm going to flip over that fraction on the bottom. So always change division by a fraction into multiplication by its inverse. Okay, now let's see what we can factor. This left fraction doesn't factor at all. It's already prime, no GCF, no possible way of factoring. But on the right, I've got the difference between 2 squares. And also notice that I've got these terms that are switched again. So I'm going to go ahead and factor out -1 so I can put them in correct order. Factoring out -1 always allows you to rearrange the terms properly, and proper term arrangement will be alphabetical. A comes before B. This bottom is already in the proper order. We'll just factor it in just a minute. Let's just go ahead and factor this numerator. It's the difference between 2 squares, so we'll write that as a plus b times a minus b. So we don't need this anymore. Don't forget the -1. Don't mark that out. But we'll look at the factored form, and then the bottom, this denominator factors also as the difference between 2 squares, x plus y times x minus y. Okay, now we can start marking out matching factors like these x minus y's. Going diagonally, we can mark out the a plus b's. And that looks like it. So I'm fine if there's probably 2 or 3 different ways of showing the correct final answer. Just leaving it like it is. You could do this, everything that doesn't cancel. You could, if you wanted to, distribute the -1, and that would make it -a plus b over x plus y. That would be okay. You could make the whole fraction negative, and that would make a minus b over x plus y. Anything along those lines, if you just want to be safe and just list out whatever doesn't cancel becomes your final answer, that's fine with me. So that's your answer for number 3. So make sure you're ready to do some factoring on this test. It's going to be very important. Okay, so we're back to in 7.2 we were subtracting and adding rational expressions. And that required us to find a lowest common denominator. And so I showed you a technique to make that happen when you're dealing with monomials. So I want to make a distinction between monomials, notice no plus or minus signs, versus over here, when we get to this problem, we're dealing with trinomials. And so the factoring is going to be quite a bit different. With monomials, you just want to basically list out all the prime factors. So let's just take 8c squared d squared, and that would be, we'll just do that over here, 2 times 2 times 2, that's the 8, and then 2 c's multiplied together, and then also 2 d's multiplied together. And now we'll do the same thing with 14, so that's going to be 2 times 7. There are 4 c's and a d. And now we start matching up what's already in common. There's a common 2. All right, so 2 is going to be part of my LCD, just 1, 2 to represent common 2s. All right. As far as the numbers are concerned, nothing else is in common, so the rest of these numbers, these 2 2s and the 7, will just be a part of the LCD. Okay, done with those. Now let's take a look at the variables, see what they have in common. All right, notice here's a pair of C's, so I need one C to represent those. Here's another pair of C's, I need another C to represent those. There are no other C's in common, so these other 2 C's will just be listed. All right, and now there is a pair of D's in common, so one D for those, and then this other D that was not in common. So when I multiply all this together, that's going to be my least or lowest common denominator. Okay, so 2 times 2 times 2, this is 8. Times 7, that's 56, and then C to the 4th power, D to the 2nd power. All right, so let's set this up. 56, C to the 4th, D to the 2nd. All right, so I'm going to try to create 2 brand new fractions where they both have the same denominator, and we know what that denominator is, but now we have to calculate what the numerator is going to be for this new denominator. And the way we come up with the numerator is you're going to divide. Okay, so just think of it this way. Divide this old denominator into your new common denominator and see how many times that goes. All right, so 8 goes into 56 7 times. C squared goes into C to the 4th, C squared times. And the D squares would just make 1, because anytime I divide anything into itself, it's just 1. So the result of this division is 7C squared. Now I'm going to multiply that times this numerator, and that's going to give me the new numerator that will go above the LCD. Okay, do the same thing here. Divide. 14 goes into 56 4 times. C to the 4th and C to the 4th would cancel. That makes 1. And D goes into D squared, D to the 1st times. So now that I've got that result, I multiply that times 3x, and that gives me 12 dx. And now I put those two together as one fraction, and I want to see if I have like terms that I can combine, but it doesn't look like I do. So it's 2 separate terms being subtracted all over the common denominator. And that is your process when it comes to subtracting, or we're going to do one over here for number 5 where we're adding. Okay, so with factoring of trinomials, a little different. We first want to look for a GCF. So I'm looking at this denominator. I'm looking for a GCF. I don't see one. So now in cases like this, you may want to consider the box method or the AC method. All right, so let's see how this factors 4x squared and 2. So remember the box method, I multiply those together. And then I try to come up with the factors of 8x squared that add up to 9x. And that's going to be 8x times 1x. And those terms fill in the other missing squares. And now I find the 4 GCFs. So across the top, that's 4x. Across the bottom is 1. Going vertically, that's x and 2. So that ends up being the factoring for that first denominator. So we don't need to look at that anymore. For the second denominator, there is a GCF. Notice that 2 is a GCF. And then let's see, this will make the factoring of the trinomial quite a bit easier. Don't have to use the box method or the AC method. I'm just going to use the factors of negative 12 that add up to negative 4, and that's negative 6 and positive 2. All right, so now it's the factoring that's going to help us come up with the lowest common denominator. So they already have x plus 2 in common among them. So that means I'm going to have x plus 2 once in my LCD. And then everything else that isn't in common, I'll just list it and include it. So that means the 2, the 4x plus 1, and the x minus 6. All right, so I'm going to set this up. 2 different fractions with the same denominator. And I'll just go ahead and erase this, give myself a little bit of room since you already saw the box method work. All right, so now let's do our same thing we did over here with the division and then multiplication. So I'll just show the arrow again so you can see it. I'm dividing old denominator into new common denominator. And if you notice, 4x plus 1 and x plus 2 cancel out when I do that. Okay, I'll just show it like this. And so whatever doesn't cancel out, which is 2 times x minus 6, I'm going to go ahead and show that as 2x minus 12. That's going to multiply by 2x. These get multiplied together. So just distribute 2x to both of these, and that's going to be 4x squared minus 24x. Okay, that's done. Now do the same thing over here, divide. And if you notice, the 2's will cancel, the x minus 6's will cancel, the x plus 2's will cancel, leaving 4x plus 1 to multiply times 3. And so just distribute 3 to both of those, and that's 12x plus 3. And now you're ready to write your fraction all over the common denominator. So start with the big exponent for x squared. Then we put the two x's together, negative 24x plus 12x is negative 12x. And then we have this constant 3 all over the common denominator, which is 2 times x plus 2, 4x plus 1, x minus 6. I'd like to see if factoring is possible in the numerator so that I can maybe cancel or reduce, but there is no way to factor this numerator. You will know that because if you multiplied 4x squared times 3, that's 12x squared, and there are no factors of 12x squared that add up to negative 12x. So can't factor. That leaves this as my final answer, and I'll circle it. And we are ready for number 6. All right, so number 6. Scroll down just a little bit. Factor again. So let's look at these denominators. I noticed that 3 is a GCF. Let's get that out of there first. And then let's see if we can factor more. Factors of negative 6 that add up to positive 1 are positive 3 and negative 2. All right, so we're done factoring that. Now let's see if we can factor this other denominator. Again, box method comes in handy here since the number in front of x squared is greater than 1. So that's 30x squared. And the factors of 30x squared that add up to 11x are 6x and 5x. Okay, find your 4 GCFs, 2x, 5x, and 3, and that's your factoring. Okay, don't need to look at that anymore. Now let's let the factoring lead us to what the LCD is. So let's see, x plus 3 is in common to both. So x plus 3 once will be a part of my LCD, and nothing else is in common, so everything else just gets listed. And I'll put the 3 out here in the front. And I'm going to make 2 new fractions with this LCD in both of them. All right, and so the way this numerator is made, I divide. All right, so again, old factored denominator divided into new common denominator, and just observe what doesn't cancel. And can you see that the 2x plus 5 is the one that doesn't match up? So that means 2x plus 5 is going to multiply times 4x. And that's going to be 8x squared plus 20x. All right, do the same thing over here with this denominator. 2x plus 5 is going into this. What doesn't cancel will be the 3 and the x minus 2. So I like to just go ahead and put those together. That's 3x minus 6 to be multiplied times 2x. So 2x times 3x is 6x squared, and 2x times negative 6 is negative 12x. All right, so with subtraction, we say this a lot, but subtraction can be tricky. It can really mess you up, so be careful. I would put parentheses around this second numerator. So when we go to combine like terms, it's going to be 8x squared minus 6x squared. That's 2x squared. And then it's going to be 20x minus negative 12x. So really we're adding here. Notice the minus negative. So really that's like addition. 20 plus 12x. 20x plus 12x is 32x. All over the common denominator. And now I notice that the numerator can be factored. There's a GCF. It's 2x. So I factored out the GCF just to see if it gives me an opportunity to cancel anything between the numerator and the denominator, matching factors. There aren't any, but if there were, I would have caught it, and that would have kept me from losing points by not reducing when I could have reduced. So there's your answer for number 6. All right. In lesson 7.3, we learned how to graph these reciprocal functions. And so this is the parent function negative 1 over x, but it's shifted. And according to this, we shifted it 1 unit to the right. So this is how I show the shift of 1 right. I take this old vertical asymptote, which was the y-axis, and I literally move it right 1. And this other number indicates a shift of up 1. So I take the old horizontal asymptote, which was the x-axis, and I move it up. And now I just have to think of a table for the parent, and I'm going to plot those table points from here, where those two lines cross. All right, don't use 0 as an input. That's not allowed, but we can do 1, and if I input 1, I get negative 1. So let's plot that. 1, negative 1. I can do 2. That gives me negative 1/2. Go back to your old or your new origin, right here where the two intercepts, asymptotes cross each other, and then plot from there. So 2, negative 1/2 is there. And I'm just going to go with 1/2. Dividing by 1/2 means to multiply by 2. So if I input 1/2, I get negative 2. So going back to here, 1/2, negative 2. And I'll use those 3 dots and then trace as though I'm approaching those two asymptotes, but technically never touching. So there's one of the branches. And then for the other branch, you just input the opposites. So you'll do -1, which gives you output 1. -2 gives you output, -1, 1, that's right. -2 will give you output 1/2. And then -1/2 will give you output 2. All right, so let's plot these. All right, so we'll plot now these the opposites of our original inputs. So going back to where these two asymptotes cross, I'm going to plot -1, +1, -2, +1/2, and -1/2, +2. And now you can see how the other branch is sketched. And the instructions don't mention anything about domain and range, so the test will be the same. You won't have to worry about that. Just sketch the graph. Now, just be aware the numerator on the test may be a positive, and so of course that's going to cause your branches to be more like this and this. The negative is what caused it to flip, so just be prepared for either, and you should be good to go. So now let's solve some rational equations. So to do this, I'm going to find out what the LCD is. So for number 8, the LCD is 6x. And the purpose of the LCD being multiplied on both sides of this equation is so I can basically clear out, or you might think cancel, these denominators. I'm going to make these two denominators disappear by dividing them each into the LCD. And then whatever the result of that division is going to be, I'm going to multiply times this numerator. All right, so let's do this. 3x divided into 6x is 2. 2 times 9 is 18. So that denominator is gone. 2 divided into 6x is 3x, and 3x times -6 is -18x. And so now I've turned a rational equation into non-fraction, and we know what to do from here. I just divide by -18 on both sides, and I get my solution is x equals -1. You just want to double check, and if you have time, you finish the test early, you want to go back and plug these in, but at the very least, before you move on to the next problem, at least check and make sure that your solution doesn't cause 0 in a denominator. If it does, then it's not really a solution at all. Okay, so for number 9, the LCD is going to be 2q times q plus 1. So that's what I'm going to multiply on both sides. So on the left side, I just have this single 2. You could think of it as denominator 1 if you like, but if you divide 1 into this LCD, then it's just the LCD being multiplied by 2. Okay, so if you want to, on the left side, you could treat this as 2q squared. What's that? 2q squared plus 2q being multiplied by 2. Okay, so just distribute the 2 to both, so that's 4q squared plus 4q, and now I'm done with the left side. Now on the right side, I'm going to divide 2q into all of this. Well, the 2 q's would cancel, and that leaves q plus 1 to multiply times 5, and that's 5q plus 5. For this second denominator, I'm going to divide q plus 1, and it would cancel out with this, and that leaves 2q to multiply times 2q, and that's 4q squared. Well, the q squares, if you subtract 4q squared from both sides, they will just become 0, or they cancel. And now putting the q's on the same side, I could subtract 5q from both sides, and then divide by -1 on both sides, and I end up with my answer of q is -5. And once again, I'm going to double check. That doesn't create 0 in either one of those denominators, so I'm good with that solution. Okay. For number 10, we also need to come up with the LCD so we can multiply both sides of the equation by that LCD and clear out the denominators. So the only thing that has to be done before I can discover what the LCD is this right side denominator needs to be factored. And once again, you could use the box method. I'm going to try to save a little bit of time. But if you went through the box method properly or the AC method, whichever you prefer, you're going to come up with the factoring that looks like this. So this would be 2x minus 3 times x plus 1 would be the factoring. So we can just mark this out. And now I can tell that the LCD, excuse me, is actually going to be 2x minus 3 times x plus 1. And that will be used to help me clear out, remove all of the denominators. Because I'm going to divide, and dividing into this LCD will make these cancel. And so then whatever doesn't cancel, like this x plus 1, I'm going to multiply by 4, and that's 4x plus 4. Now the x plus 1 will cancel, leaving me with 2x minus 3 to multiply times x. 2x squared minus 3x. On the right side, everything cancels. That's another way of saying 1. If you divide anything into itself, it equals 1. So 1 gets multiplied times negative 8x. And now I'm going to combine like terms on the left. 2x squared plus x plus 4 equals negative 8x. And it looks like we're going to end up with a quadratic equation, and they need to equal 0 so I can solve them. So if I add 8x to both sides, I end up with this quadratic equation. Once again, the box method would be helpful. We had a problem on your last test where you had to solve by factoring. You could also, if you wanted, you could solve this using the quadratic formula or completing the square, but factoring is possible. So once again, if you need the box method or the AC method to help you with this, but the factoring would look like this. And don't just factor and stop. Remember, we're solving, and there's two different answers that we're going to come up with as solutions. So think of each of your factors as separate equations that equal 0. And so that will help you with the solutions. So negative 1/2 is the solution for that factor. And then negative 4 will be the solution for the other. So those are my two solutions. I'm double checking, making sure that neither one of those numbers create 0 in a denominator. And so we're good to go. All right, number 11. The LCD is going to be 15x. Oh, sorry. 30x. And if you weren't sure how'd you get that, well, again, 2 times x, that's the factored form. 5 times x, factored form. The 3. They have a common x already, so there's the x, and then nothing else is in common, so I just multiplied these together. 2 times 5 times 3 is 30. So now we can divide. 2x into 30x is 15, and now multiply 15 times 1. 5x into 30x is 6. 6 times 4 is 24. On the right side, 3 into 30x is 10x, and then 10x times 1 is 10x. So the left side becomes negative 9, and then dividing by 10, you get negative 9/10. See if that makes 0 in either denominator. It does not, so good to go. And now we're going to do some inequalities. These are a little bit different. They're a little bit more time consuming. So let's take a look at how these work. For inequalities, the first thing you should do is identify numbers that x cannot be in order to prevent division by 0. And right off the bat, I see that x cannot be 2 because of this middle fraction. Now I'm just going to treat this as an equation, just like we did in the previous problems. We're going to temporarily pretend like this says equals instead of greater than. All right, and so now I got to come up with the LCD, and that's going to be 12 times x minus 2. So all I'm doing here is showing that I'm multiplying by 12 times x minus 2 on both sides to get rid of these denominators. All right, so 3 goes into 12 4 times. So the result of dividing, I'll just do some work up here. 3 goes into 12 4, and that leaves me with 4 times x minus 2, and that's 4x minus 8. Okay, just want you to see that. 4x minus 8 now multiplies times x. And that's 4x squared minus 8x. Okay, now this denominator, x minus 2, divides into the LCD, and that leaves me with 12. The x minus 2's would essentially cancel out, and so 12 multiplies times 1, or negative 1, and that gives me minus 12. Over here on the right side, 4 is going to divide into 12. It's going to make the 4 go away, and that leaves me with 3 times x minus 2, which you could think of as 3x minus 6. All right, so I'm going to think of it as 3x minus 6. Now I'm multiplying these together. And this is going to be FOIL. Whenever I multiply two binomials together, that's going to be the FOIL method. So first would be 3x squared. Outside would be negative 6x, inside would be positive 3x, and then the last would be negative 6. And when you put these two together in the middle, I just want you to see it, it'll be negative 3x. So I'm just going to change this into minus 3x. Okay, so looks like we're going to end up with another quadratic, so we need to make it equal to 0. So I'm just going to take these terms, undo them so that the right side becomes 0. So subtract 3x squared, add 3x, add 6, and now we're going to solve by factoring. The factors of negative 6 that add up to negative 5 would be negative 6 and positive 1. And so my two solutions from the equation form of this problem are 6 and negative 1. So now this is where a little bit of work is going to come in. I'm going to take these three numbers and I'm going to put them on a number line. And let's see, I'll start just in order, negative 1, 2, and 6. And just think of those three numbers, breaking your number line up into really 4 sections. And you're going to pick a number, one number out of each of the 4 sections to do a test. Okay? So let's see, I'm going to just pick negative 2 to represent this section. I'm going to pick 0 to represent this section. Something in between. I'm just going to pick, let's just go with 3 and 7. So those are the numbers, one at a time, I'm going to put in for x. And I want to see if this number that I've chosen, that I've circled, makes this original inequality become true. All right, so since I've already completed this, let me see if I can work up here, and I'll show you one at a time how the test works. Now I don't really use fraction or calculators for this. I just work with fractions. So if you have questions how to use your calculator, just talk to me in class and we'll work that out. Okay, so here is testing negative 2. All right, I put -2 in for x here, and then I put -2 in for x on the bottom, and I'm trying to see if the left side is going to be less than the right side. Okay, so -2/3. This is going to be minus -1/4. And I'm trying to see if that is less than, not or equal to, just less than. And this would be -1/4. Okay, so -2/3 plus 1/4 less than -1/4. Okay, so if you can't see it, let's change to a common denominator, which would be 12. So this would be -8/12. This would be positive 3/12. And is that less than -3/12? Okay, so the left side becomes -5/12. And since -5 is less than -3, then -5/12 is less than -3/12. So we've proven that this area, all the numbers less than -1 are going to make the original problem true. So I'll put a check mark there. Okay, so I'm just going to erase when I'm done checking, but I wanted you to see how this check works. Okay, so now let's go to our next number, and we're going to see if the numbers between -1 and 2 work. And we're going to use 0 to represent those numbers. Okay, so if I let x be 0, 0 divided by 3 is 0. This next fraction becomes 1 over -2 because 0 minus 2 is -2. And I want to see if that is going to be less than 0 plus 1 over 4. All right, well, 0 plus 1/2 is 1/2. And is 1/2 less than 1/4? Well, obviously not. That's not true. So these numbers do not work. I'm going to put an X to represent all the numbers between -1 and 2. They will not be solutions. Okay, let's try 3. All right, going back to our original inequality, plugging 3 in for all of the x's. So 3 over 3, if you let x be 3, that's 1. And if you let x be 3 here, that's going to be 1 over 1, which is, again, 1. So I'll just write it as 1. And I want to know if that is less than 1 plus 1, which is 2 over 4, which is 1/2. So is 0 less than 1/2? Yes, it is. So these numbers work. The numbers between 2 and 6 are good. And now we just have one more test, and that's going to be plugging in 7. So let's erase these. So 7/3 minus 1 over, and this is 7 minus 2, so that's 1/5. Is that less than 7 plus 1 is 8 over 4, which is 2. Okay, so if you have to get a common denominator, that would be 15. So this is 35/15, and this is 3/15. Is that less than 30/15? All right, so these two would be 32/15. And 32 is not less than 30, so 32/15 is not less than 30/15. So these do not work. So we are ready to finalize our answer. All the numbers, x's, that are less than -1 are answers. We proved that. Or we have x's that are between 2 and 6. Those also worked. And so here's how we show that between statement. So there's your final answer for number 12. All right, number 13 is similar. We start off by finding the number that x can't be. X can't be 0. Now we're going to solve this as though it were an equation. So just treat it as though it said equals, and find your LCD, and that's going to be 15x used to clear out the denominators. So 5 times 15 is 75. 5x goes into 15x 3 times. 3 times 6 is 18. And then 3 goes into 15x 5x times, and 5x times 2 is 10x. So adding these together and then dividing by 10 gets the solution to the equation. And so now these numbers, this 93 tenths and this x, the x can't be 0, they're going to be the two numbers on our number line. And we will test around. So if 93 tenths, you can think of that as 9.3 or 9 and 3 tenths. Okay, so there's 3 areas that we need to test, and we need a representative number from each area. So I'm going to use -1 for this area. I'm going to use +1, and I'm going to use 10. Okay, and we're going to go back up to our original problem. So if I let x be -1, let's give myself a little bit of room up here for the test. If I let x be -1, that makes -5 plus -6/5, 6 over -5, it's -6/5. Is that greater than 2/3? Well, two negatives added together are going to give you a negative result, and a negative answer is not going to be greater than +2/3, so these numbers do not work. Now let's try 1. If I let x be 1, I get 5 over 1, which is 5, plus 6/5. Is that greater than 2/3? Well, obviously 5 plus, it's already greater than 2/3 before I added 6/5. So these numbers do work. And let's just go ahead and try 10. If you let x be 10, so 5 over 10 is 1/2, plus 6 over 50. Is that greater than 2/3? So I guess we need a common denominator, which would be 150. That would be 75 over 150. This would be 18 over 150. Is that greater than 100 over 150? Well, this left side is 93 over 150. 93 is not greater than 100, so these do not work. And so our final answer will be all the numbers between 0 and 9.3 or 93 tenths. Okay, that's how those inequalities work. You'll have some of those on your test. Here's a review of some Chapter 5 material, the square root function. And so the square root function begins, its parent is identified for us by these 4 points. So make sure you go back and refresh your memory on how we got those. It's just perfect square root numbers, 0. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and the square root of 9 is 3. And then applied to these 4 points are really 3 things. I'm going to start with multiplying by -2. Then I'm going to do the shift, and this means 2 to the right. And then I'm going to do the shift of 1 up. So just go in that order, and you'll be in good shape. The -2 only multiplies times the y coordinate. So for this origin point, the y coordinate is 0. 0 times -2 is still 0. So that had no effect. Multiplying by -2 did not do anything to this origin point. Now I'm going to shift it 2 to the left, 2 to the right, and 1 up. And so the origin point became transformed into that point, 2, 1. All right, and now let's take a look at 1, 1. When I multiply times negative 2, it becomes 1, negative 2. Now I'm not going to, you don't have to leave your dot here. I just wanted you to see how multiplying by negative 2 has this effect. It turned 1, 1 into this point. And now I'm going to do the translation of right 2 and up 1. So that's going to be the final resting place of that second red point. Okay, so maybe you won't be so confused. We're done with these. We've transformed these, and now I'm working on the third red dot right here. So once again, when I take this point, it's now 4, 2, but when I multiply by negative 2, it becomes 4, negative 4. Just multiply the y. So right for now, I'm just going to make a dot there. It's not going to stay there because I'm going to do these two shifts. Right 2, up 1, and that's where it lands. Okay, that one's done. And I got one more. 9, 3, when it gets multiplied by negative 2, becomes 9, negative 6. And then I go right 2, up 1, and that's where it lands. And this is going to be the graph. And now I state the domain and range, and I'm done. So the domain is going to be all x's that are greater than 2, greater than or equal to 2. And the range will be all y's that are less than or equal to 1. Because the graph is going down forever. Okay, let's take a look at number 15. This is a log equation, and actually it's a log equation where there's two different logs. So we have a property, it's called the product property, that says two different logs that are being added get joined together as one log using multiplication. So I'm just going to show what's happening here. So I'm applying the product property. Okay, so there's the application of the product property. And now I'm going to, you always want to convert, once you've consolidated or brought all of your logs together, made them become one, you want to change log equations to exponential form. So the exponential form of this will be 3 as a base raised to the power of 3, and that's going to equal 3a squared plus 9. Okay, well 3 cubed is 27. So now I'm going to subtract 9 from both sides. I get 18 equals 3a squared. I'm going to divide by 3. And now I'm going to do the square root of both sides. And you can just leave your answer as a simplified radical here, since the directions don't say anything about rounding. So that means don't give me a rounded decimal. And so in this case, we always want to be aware of the fact that we can't do the log of a negative number. But in this case, if I do put a negative number in for a and square it, it becomes positive. So be careful here. Some of you just assume that the negative is never an answer, but in this case, it actually is. We have two answers. Positive root 6 and negative root 6 will be our solutions. Number 16, I'm going to put these two together. These are two separate logs being subtracted. They go together as one log using division. And now same thing, change log form to exponential. So the base of 4 raised to an exponent of 1 equals this fraction. And I'm going to multiply by y minus 2 on both sides to clear out that denominator. So 4y minus 8 equals, those are canceling, and that equals 2y plus 2. solve for y, subtract 2y from both sides, add 8 to both sides, and I got y is equal to 5, and 5 does not create the log of a negative or 0, so we're good to go. Now we leave log equations and we go to exponential equations. So the procedure is going to be reversed. Instead of going from log to exponential, we're going from exponential to log. And the way I do that is I do log on both sides. And now I get to apply this property called the power property, which says bring down the x plus 2 and multiply by it. And now you can undo multiplying by log 5 with division of log 5 on both sides. And now you're going to go to your calculator, and I'll go to mine, and we're going to do log 9 divided by log 5. And there's a decimal sitting there. It's 1.36521238.9. And so I'm just going to leave that there, and to solve for x, I'm going to subtract 2 from that number to get my final answer. And so x is going to be negative 0.6348 rounded to, this is, we're told here to round to the 10,000th, which is 4 decimal places. Okay, number 18, same process, a little bit longer, a little bit more work involved when there's variables on each side. And so I'm going to do log on both sides. Power property on both sides. When the variable is on both sides, I've got to work to get the x log terms on the same side. So I'm going to have to do the distributive property here. Only necessary when you have the variable on both sides of the inequality or the equation. So here we go, distributing. And now I want to put x logs on the same side. So I'm subtracting x log 4, and I'm adding log 3. And now with the x logs on the same side, I can factor out x. And now I'm going to go to my calculator, and I'm dividing. Let me just show you what I'm doing here. I'm going to be dividing both sides. So since I'm multiplying here, I'm going to divide both sides by log 3 minus log 4. So be careful the way you use your calculator. I'm hitting log 3, close parentheses, divided by, and then a set of parentheses, or left parentheses, log 3, close parentheses, divided by, minus log again, and then 4, and then 2 right parentheses. So I'm going to read off that denominator. So you have left parentheses, log 3 enclosed in parentheses, minus log 4 enclosed in parentheses, and then another right parenthesis to enclose the whole denominator. Okay, so I'm going to hit enter, and I got negative 3.8188. The thing that you got to be careful with here is solving for x. I'm dividing both sides. Since 3 is less than 4, that means 3 minus 4 is going to be a negative number, which means log 3 minus log 4 is also a negative number. So when you divide by a negative number, you have to remember to reverse the inequality. So you got to really be careful and pay attention to whether or not you're dividing by a positive or a negative. And there's my answer for number 18. And we're almost done. Number 19, these are natural log equations, so I'll give you a couple of little tips here. Isolate natural log, and then change to e to the x. Okay, so to isolate natural log, to me the easy way to do that is just divide by 5, in this case on both sides. And now we can do this. Natural log 6x equals 8/5. That means e, whenever you have natural log, the base is e. E raised to the 8/5 power is equal to 6x. So the beauty of this is I couldn't do anything with this in my calculator, but I can do everything now with my calculator. So go to find the e to the x button and put in 8 divided by 5, close the parentheses, and you can hit enter there or equals, and then divide that by 6 to solve for x. And to the nearest 10,000, that's 0.8255. Okay, well over here we isolated natural log to change to e to the x. Here we're going to isolate e to the x to change to natural log. Okay, so two things. We need to add 3 to both sides. We need to divide by 6 on both sides, and if you want to reduce that, you can. You can make that 19/3, or you can just leave it 38/6 because it's going in your calculator anyway. So we've done this. Now we need to write this as a natural log equation. So natural log 38/6 or 19/3 equals x. So go back to your calculator. This time you're going to hit the LN button and do 38 divided by 6. And that is, after rounding, 1.8458. And that's it. That is the material that I am going to require of you on this next test. So I hope this is beneficial to you. If you do have any questions, feel free to reach out to me, and I'll be glad to help you.